Hello everyone. In the last tutorial, we studied about vertical scaling. In this tutorial, we are going to learn about horizontal scaling. We'll begin with what is horizontal scaling. In simple word, it means we are adding more nodes instead of scaling hardware on one single node to manage the incoming requests. Now, what do I mean by node? Node is simply your machine or your server. Okay. We can understand the difference between horizontal scaling and the vertical scaling very beautifully through this example. So let's imagine a situation where we have one laborer who is involved in constructing a house. Initially, you gave him about, let's say, an year to complete, which seemed ample enough of time to do with 8 hours daily taken into consideration. Okay. Now, suddenly you reduced the time to 6 months because of some Z reasons. Now this laborer, the single person, right, who was managing till the point, he was managing everything. Now he started working 18 hours in order to meet the requirement within the deadline. However, now you wanted the house to be completed within 2 months. 18 hours was the limit for the laborer. Now he cannot bear to work alone on this project anymore because the load is too much on him. Hence, you provided him with 10 more laborers to do the task. These are the 10 more laborers. Okay. Now, the amount of work along with the time was distributed between all these 10 laborers, thereby leading to easy completion of task. You can draw a similarity with load on one laborer to vertical scaling and distributed load between 10 laborers to that of horizontal scaling. Okay, hope this picture helps you in providing clear cut knowledge in terms of horizontal scaling and vertical scaling. So whenever you have too many machines, right, which can cater to all the incoming requests, so the workload gets divided. How does this workload gets divided? That is a different concept of mm, system design. Will come to that. That comes as part of your load balancer. But since there are three, let's say 10 such nodes which can cater around 700, 800 requests on a daily basis, it becomes easier to define. So if I have 10 such nodes, and if let's say I have on a daily basis, I have let's say 1,000 requests, so obviously I can assign some 1,000 by 10, that is 100 requests on each node. So this will help me in faster processing of all the requests as well, and my nodes won't be overutilized, or um uh, it won't be a situation where I will land up to completely going down of machine just because it has too many requests. Correct. So that is what horizontal scaling was, and the difference between horizontal and vertical scaling. Now, how do we achieve this horizontal scaling when we say there are multiple nodes? So are we going to keep the same code deployed on all these machines? Um, how is it, let's say if my single laptop right now is having the database as well, how are the data going to be stored when there are multiple nodes, right? All those questions comes into picture. So we'll be discussing some important concepts like replication, sharding, clustering. Most of these concepts come as part of distributed databases as well. You can There is a very good blog on MongoDB where you can study, because they make use of this horizontal scaling, and very beautifully they have explained what is replication, sharding, and clustering. You can go through them if you want. Okay, I'll be discussing in the further videos, but in case you want a heads up, I think it would be good to go through it. Now, coming to the point, when to use horizontal scaling. So, to be honest, nowadays almost every platform uses horizontal scaling because of the amount of requests on a daily basis the organizations are getting. So, um, load can exponentially increase. You never know when is the incoming request going down, when is the incoming request is way too high. So because of this unpredictability, I think it's best to use horizontal scaling. We don't know the limit of request it's going to be. Then I think it's perfect that we go for horizontal scaling. What are the advantages of using the horizontal scaling? The best and the biggest advantage that you get, first thing is you get any amount of huge request. You can scale your nodes up to any point, right? So this makes it, the best choice for choosing horizontal scaling. Vertical scaling, there is a limit up to which it can scale and it becomes useless after it. I hope that explanation was hopeful, that one laborer versus 10 laborers. So, if I'm going to construct, let's say, a whole city itself, obviously that one man can never complete it. It's going to take huge amount of time. So obviously, we have as many resources, right? The work gets divided. Someone is responsible for the core town. Someone is responsible for outskirts. Someone is responsible for the shopping center, etc., etc. Right? So the workload gets divided. Hence, the biggest advantage you get in horizontal scaling is the amount of requests that you can handle is it could be any amount, right? So that is one of the biggest advantage. Disadvantage, because since there are a lot of nodes, I mean there is a lot of maintenance also you have to take care of. There is a lot of complexity involved. How are these nodes gonna communicate with each other? At what point, I mean, if let's say on a particular day the request instead of 600 it's only 100, are we wasting our resources? Because I have 10 nodes deployed anyway, even though it is 100 requests, only on the one machine it is getting routed to. So are we wasting any such resources? So all those complexities comes if we are increasing machines, then how reliable my system is going to be. All such questions manifolds manifest itself when it comes to system design. I hope it was clear what is horizontal scaling and when you should go for horizontal scaling. What is the difference between horizontal versus vertical scaling? I think I hope this picture made it a lot more clear. Please let me know if there's anything that else you would like to learn or discuss about in the comment section. Thank you. Bye bye.